Hi, this is Dana Price, and welcome to our J4K.io session. I am a senior technical staff member and app modernization architect at IBM, and I'm joined by my colleague, Len.
Hi, I'm Len Theivendra. I'm the MonotoMicro architect.
So we're glad that you joined us, and we're going to be talking about modernizing our Java workloads to cloud native on Kubernetes. And if you have any questions as we're sharing, please do put your questions in the chat and we'll try to adjust them as we're going. So our session today, while it's talking about modernizing our critical Java workloads, is going to be focusing on retaining as much of the value as we can of our critical Java applications while we're modernizing. So when we modernize, there's a common concept of the 6 R's that illustrate the choices that we make with respect to each and every application. And there's not one choice that is appropriate for every application, but instead we have to kind of weigh the costs and benefits related to each application, its needs and its dependencies. The first 3 in the list here are retain, retire, and repurchase. And they all leave that application as it is, where it is, at least for a while, or they entirely replace it with a service that's available in the cloud. But the next 3 are the ones that give us the chance to keep the valuable intellectual property and functionality of an application that we've invested in over the years, and still be able to achieve the benefits from cloud optimized runtimes, Kubernetes environments that we exploit today when we're starting our cloud native development processes. So by rehosting our application or lifting and shifting it, that we're able to move that application without substantial or any application or configuration changes. And by doing so, we can participate in the agile DevOps processes that we have already established and are using for our cloud native development process or cloud native applications. And that in itself is a benefit. And that doesn't require any code changes. By replatforming our application, which can mean a lot of different things. It could mean containerizing that application with its existing runtime. It could mean deploying those containers and running them in Kubernetes and taking advantage of the Kubernetes orchestration. Or it could mean both of those and changing the runtime that the application is running it within, still without changing the application substantially. And if we did such a thing, then we'll get that DevOps benefit that we had from just rehosting, but also be able to reap more benefits that are closer to cloud native. So we can reduce the costs of deploying and running that application with our lighter weight runtimes, such as the Open Liberty runtime, IBM WebSphere Liberty, which are composable and have a smaller memory and disk footprint that matches the needs of the application. We can reduce costs through cloud pricing models. So as our application is running and needs to be scaled out, we're going to pay more because we're using more of the cloud resources. And when the needs are lower, then we're using less of those resources and having a better cost model there. We can also, by adopting our containerized patterns, be able to confidently move from development through test and into production and maintain some consistency through the use of those immutable container deployment images. And then lastly, we're able to achieve agility and scalability for that application throughout its life cycle. So scaling up and scaling down, being able to have rollouts of updates and backing them off when we didn't want them. And then lastly, the last one is the one we're going to be focusing on today, which is refactoring or re-architecting an application. And that's one of those that typically is the highest cost. It involves modifying the application structure into microservices. And we can maintain and benefit all the ways that we had in the previous items, but also be able to add a whole lot more to the agility of and the innovation behind our application. And since that is typically something that happens, costs a lot in terms of re-architecting, redesigning, re-implementing all of the code, also re-implementing all of the tests to ensure everything that we depended upon in the past with that monolithic application still can happen with the new microservices-based application. It's typically something that costs a whole lot more. But what we have, and today we're going to focus in on, is a new project that we have called MonotoMicro. And what it allows us to do is refactor an application into microservices while retaining as much of the original application and the code associated with the application as we can. And what MonotoMicro does is it uses observations about that application while it's running and while it's executing those business critical use cases to determine the ideal sections of the monolithic application to deliver independently as microservices. And it uses those observations that include the frequency of interactions between the classes, the objects that are exchanged between classes, and how the classes are used together during particular business use cases to recommend the ideal partitions. And that's what Len's going to show us today in his demo. So it's an exciting project, and we're excited to tell you about it.
All right, great. Thank you, Dana. So MonotoMicro, and how does it work at a very high level? So basically, you have your Java monolithic application and its source code base. And what MonotoMicro does is it first asks you to analyze that source code base using its tool, just to analyze the source code and infer any and existing class dependencies and other kinds of code dependencies that's maybe in the application. And it also then will instrument that application. And here's the key now. Once the application is instrumented, it asks you to run it through various use cases, or what we call use cases that's aligned to functionality, trying to exercise as much of the functionality of the application as possible in order to exercise as much of the code base as possible. And while you're doing that, due to the instrumentation, a lot of logs will be collected. And within those logs, MonotoMicro tries to capture the information in order to help the AI engine infer what class is calling what class and at what time in what use cases, right? So after all of that data is collected, then all of that is fed into our AI engine, which then uses various machine learning algorithms to try to partition the app into groups of classes, each partition having a group of classes, and those partitions will be serving as a starting point for a future microservice. Now, how are those classes grouped? It uses AI and ML and hierarchical clustering algorithms based on the use case data, as well as the inferred dependencies in code. So for example, it'll try to group classes which are in the same use cases as much as possible into one partition, and try to minimize flow of execution between partitions to try to isolate the groups of classes to be as independent as possible. So once all of that data is collected and you have run the AI engine on that data set, then you can view the analysis in our UI, which I'm about to show next, where you can gain insights into the existing behavior of the monolith, as well as how the AI has recommended the partitioning. And you can further customize those partitions. And then finally, after you have customized them to your liking, you can then run our code generation tool that tries to preserve as much of the existing monolith code base as possible in the original Java classes, but generates extra classes that are meant to be wrappers to facilitate the communication between the classes once they have been spread across the partitions. All right, so let me start to share my screen and we will show the UI here. Okay, presumably folks can see my screen. All right, so here we are in the UI, and what you're seeing here is the partitioning recommendation that the AI has come up with. So let me explain some basics here. So what these boxes or rectangles represent is a partition. What the circles represent are the actual classes in the monolith application. And what these lines or edges between them represent is the observed flow of execution from class to class. And MonotoMicro was able to infer that from the use cases that the user would have run and the logs collected from that. So in this case, if I zoom in a bit here, you can see that there's a class called TradeBillDB, and MonotoMicro has observed there was flow of code 3 times from this class to that class. And what that means very likely is a method is being called from one class to another. Just one more example here. If I go within the partition itself, there's 2 times here it's been observed, and here there's 150 times or more has been observed flow of code or flow of execution from class to class. So this is actual evidence that's being observed and not potential method calls based on a call graph, purely based on analyzing the source code, right? So this is actual use cases being run, and the MonotoMicro observes the flow of execution, and considering both that as well as the existing dependencies in code, it has partitioned the app like this. Now, what are those dependencies in code that's important to consider when you try to refactor your monolithic application? One is what we call class containment dependencies. This is when one class is using another class as a state variable. Now, that is important because once you have that kind of a dependency, then the state of the containing class is very dependent on the state of the other class. So if they're going to be broken apart into different partitions, then that's an important factor to consider when you refactor the app. The method calls from class to class obviously is also a kind of dependency, and that's been shown here. And our code generation actually facilitates those calls as remote web service JAX-RS-based calls. I'll talk about that in a bit. This is in our code gen, but at least that kind of dependency is at least shown here, and it can be handled even if the classes are separated, because what used to be direct method calls can become REST API remote calls. Some other kinds of dependencies or insights one can gain. So here in our UI, you can choose to filter what you see here by use case. So this is a stock trading application that I have here as a demo that I ran various use cases through. So a typical use case in a stock trading application is to go through the process of actually buying a stock or selling a stock. So I ran those 2 use cases, and MonotoMicro would have then observed all the exact classes that got executed or were involved in running those use cases and the flow of code from method to method within those classes. So if I only wanted to see the code involved for that, I can go here and choose to just see my 2 use cases for buying and selling stocks. So trade buy and trade sell. I can apply a filter. And now I see, okay, most of the code that was involved in these 2 use cases are in partition 1 currently. There are some in partition 2, and there's one holdout here, a single class that's been placed in partition 3 by the AI. But this kind of tells me maybe in customizing this partitioning, I might want to move this class, for now at least, to be in partition 1, because that's where the other backend classes are, specifically the entity classes, for example. So that's one kind of insight one can gain in this UI. Let's reset the filter. Another kind of insight is the flow of execution, and not just the number of different potential or observed flow of code or runtime calls between partition, but the volume of them, because that matters as well. Specifically, if you see, say, one edge here, like I just hovered over here, it was observed 142 times, and that's a lot of calls between classes across partitions. And that speaks to a tighter coupling that I would like. So I want to be able to see what those heavy hitters are. I can come in here and say, okay, let me just show me the edges that was observed over 1,000 times, let's say. Apply the filters, and I see now, okay, these are the guys that I want to be a bit more concerned about, specifically when I'm customizing this partitioning and further refining my partitions. Let's reset the filters again. Another kind of insight, and this is insight into the existing application itself, is what we have called here unobserved classes. So when I go into the table, I see a whole list of classes here from the monolith application that MonotoMicro knows was in your input source code base for the app, but it did not see getting executed at all in all of your use case runs. So that could then mean one of 2 things. Either you have not run enough use cases to cover the entirety of the functionality of your app. So poor coverage, it speaks to the need for more use cases being run. Or it means, you know what, you did run all of the viable use cases for the app, but yet this code was not executed. So that could then point to this being potential dead code that's no longer needed, and no need to be concerned about these classes when it comes to factoring out refactoring the monolith to the new microservices. So again, insights into potential dead code is one thing that one can gain by having run actual use cases on the app and then using MonotoMicro's tools here. All right, two different kinds of partitioning that MonotoMicro proposes here. You'll see here, I'm in this view called business logic. And what that is MonotoMicro's AI purely just considered the use case runs, and it turned a blind eye intentionally to existing dependencies in code, such as inheritance between classes or class containment when one class uses another as a state variable. It intentionally turned a blind eye to that and just considered the use case runs, and then based on that metric alone or on that data set alone, it proposed these partitions. So that tends to lead to a more disruptive partitioning of the monolith, but potentially a more useful partitioning, because these partitions are aligned along business use cases and business use cases alone. But you'll see there's more crosstalk between partitions, and that's a necessary and sometimes expected impact of the partitioning. But let's go to the natural seams partitioning. And so what natural seams partitioning does is MonotoMicro just takes the business use case logic partitioning, where it's considering the run use cases, but also takes into account existing dependencies in code and tries to group any classes that have dependencies on each other, like class containment, into the same partition. And this can lead to a more conservative partitioning, a less disruptive partitioning, larger partitions, but maybe not as useful a partitioning. But again, if you do want to use your existing code as much as possible in your refactored version of the app, or at least as a starting point, without rocking the boat too much, then you want to preserve those existing dependencies into the same partition as possible. This is a good starting point here as well. And also, say if you wanted to take a strangler pattern approach to refactoring your monolith to partitions, where you want to carve out a single microservice that's fairly independent and still serves a good specific functionality, like maybe this one here or this one here, you can carve that out and leave the rest of the monolith and go from there. And that's what I'm going to talk about next when I go speak about the custom view. So what the custom view allows you to do is you can, let me just show you a quick example here. You can drag classes from partition to partition to drop them in, or you can move them into a new partition by going to the empty space, and MonotoMicro will let you start creating new partitions. You can also rename partitions and so on and so forth. So what I've done here is I've created two partitions, left the monolith most as it is with the bulk of the classes, but I identified from the business logic view that this partition here, let me go back to business logic, that this partition here was a good starting point for a single microservice that I could strangle out, kind of focusing in on the stock change monitoring facility. And I called it like that. I just called it stock change tracker. And then I put in some classes in here, mostly left that partition as is, and everything else into a microservice, into a monolith still. So this now represents a single partition strangled out as a good starting point for a future microservice, and leave the rest as a monolith. And this is an incremental way to start to refactor your app, where you don't go with the big bang approach and just partition everything all at once into microservices, but start off small. Right, what else can we talk about here in terms of partitioning? So once you have the customized partitioning to your liking, you can then use our code generation tool, which I'm not showing here, but it's a tool that can be run separately outside of the UI that takes as input whatever partitioning that you're happy with, which could be the default ones that came out of our AI, like the business logic one or the natural seams one or the custom one. That, along with the original input source code base for the app, is then fed into our code gen tool. And what our code gen tool aims to do then is, and here's the main premise, it keeps your monolithic Java classes completely as it is without any change. And all it generates are wrapper classes, both service classes and what we call services and proxy stub classes, pretty much like Java RMI, where, for example, if you look at a class like, say, let's pick this class, for example. This is a very heavily trafficked class, trade config here. Let me zoom in a bit. You can see it better. It is heavily trafficked by classes in its own partition, but that's okay, because that's going to remain as a single partition or app on a app server. but it's also called into by classes outside of its partition. So once that is done, MonotoMicro then identifies that as a special class. It calls it a service class. And then what it does is it generates a service wrapper for that class, as well as a proxy wrapper for that class in this partition. So what that means is that in terms of the service class, the methods are the exact same signatures as the original monolith class, but under the covers, it acts like a web service for this class, exposing all of its public methods as REST endpoints. And then the client code here, the proxy stub on this end, will also have the same method stubs, the method signatures, but in its body, it acts like a JAX-RS client to that service. So any code in this partition that was expecting to compile against and call into the original monolith class can still do so using the stub class. It's none the wiser, but under the covers, the generated code facilitates a remote communication from this class to that class in the partition. So that's basically the general premise of the code gen. And it'll do that for all the necessary code. And then that gets you accelerated on your journey to implement these partitions as running mini applications or microservices down the road. You want to get to even more independent microservices where you want to get rid of any crosstalk, which is not desired. And that will then necessarily involve rewriting of code. But at the very least, with the code gen, you can start to realize these partitions and get them running without changing a single line of your monolithic code. And that's one of the main premises that Dana was talking about behind MonotoMicro. It tries to retain as much of your monolith application's existing code base as possible, if you want.
And the other part of that is also to retain and be able to validate that first, strangler or first action through the existing test cases. So you can run it through, know then you've separated out things appropriately, and then be able to harden your service APIs, get to the point where you're able to make the code changes in order to truly deliver these entirely independently.
Exactly.
So, awesome. All right. So do we have any questions in the chat? Not seeing any.
All right.
Yes, they're coming. They're coming.
They coming? Good.
Yeah, I'm gonna go ahead and paste them in the chat here.
Okay.
So you can see them.
Okay. Before we get to the question, I wanted to touch upon one other thing that I think is also quite useful. It's a kind of insight one gains as well in the UI. Like, for example, if I click on this class here, log, I see in the initial partition recommendation, it's being trafficked quite well and quite a lot by classes from all partitions. And knowing what I know about the monolith, I know it's a fairly simple class. It's very utilitarian. It's essentially a POJO. So then that tells me, okay, do I really need to make this part of a service, or is this more of a utility class that can be packaged along with all the partitions of microservices? So again, just purely from the UI here, after the partition recommendations, based on the observations, you gain those kinds of insights as well. So yeah, just wanted to call that out. Let's see what questions.
In terms of the questions that we had, we also can, through the customization, you can take into account things that aren't purely technical, that your team structure, that the organization goals, and be able to customize. So the customization piece allows us to customize based on what our organization knows about the application and its needs.
Right.
So one of the questions, Lynn, how far do you take the refactoring effort?
Right. So that is, entirely up to the particular needs of your refactoring needs and journey, right? So one could start off with a incremental approach, like I was saying, where you want to start off slow. You just want to identify one or two microservices. So you use some strangler pattern techniques to extract out a microservice or two, and then leave the rest as a monolith and not rock the boat. And then you get that version of the app running and in production to see how that's going, to see if further refactoring is needed or not. Or you can take it as far as you want, where you do take these recommended partitions, implement them as is, and then start to rewrite some original code in order to make them more independent and self-contained, and therefore more scalable. So it all comes down to what your particular needs are, I think. I don't know, Dana, if you had anything to
I
add to
think
that.
that ties in with the next question, which is the ultimate goal to get an application completely built around microservices? I'll take that one. And really, there has been an industry teeter-totter or swing that for historical reasons, applications were monolithic and were all executing sometimes within exactly the same process. And then it got to be, oh, it's cloud. Everything needs to be services and it needs to be up into little tiny pieces. And depending on the architecture and the service needs and reusability in terms of, is it worth me going through the effort to publish this independently and make it available as a public service or more broadly used service? The answer is it's probably not an ultimate goal of a modernized application is to be completely microservice based, because it was written initially with an architecture that assumed you could have all these communications between pieces and parts. But it may be that the way that your application has evolved could be very nicely broken into microservices, because the evolution of the application might have been evolving toward more of a services architecture. So I don't think there is a goal of only delivering microservices, but if you know that a part of your application needs to be scaled differently, perhaps you have a front end that is a particular style and you want to have multiple front ends for different needs, you can carve that out, strangle that out, and use those use cases in order to get the recommendations of how that can be done. And then you can start with those service APIs, be able to then have independent deliveries that can consume them. We have another question, which is, have you seen instances where simply containerizing an existing application was sufficient? And I think we don't have an answer for that one, Lynn.
Wait, was that for me or was it, are you gonna take that, Dana?
You go for that one.
Yeah, I mean, absolutely, there could be cases, there have been cases where just simply containerizing an application is good. It all comes back down to, again, what your needs are for your end goal for the modernized platform, especially if it's an application that's maybe already has well-defined services that was running as a monolith. Say you had some existing REST endpoints defined as Java Web Services, and there were not too many entanglements in the code already, and they were fairly independent. You could gain a lot by replatforming it, i.e. containerizing it, and then moving that to a modern runtime on the cloud. Definitely.
Yeah, and I think in the beginning when we talked about those 6 R's, about refactoring and replatforming, that the choice is really what that application you're using it for today, and its dependencies and what its needs are, and your needs of it, whether it can be then delivered independently. And a monolithic deployment gives you a lot of value from its existing runtime. If you're in VMs, go into containers, you've now got that immutability benefit of being able to take the same deployment and move it, put that in an optimized runtime, so your application monolithically already behaves better because you're in a more modern architecture, and then also able to take advantage of containerized deployments. So I think we're very close to the end of our session, and want to thank everyone for your attendance.
Yeah, actually, I'm sorry. Yeah, you still have 6 minutes. My apologies. I gave you the wrong cue. Yeah, you have until 3:35.
Oh, good. Okay.
You got like 5 extra minutes.
And if you have any questions, drop them in the chat, because you got
I'd be happy to answer.
Rich new 5 minutes. We do have one, which is, are there areas of modernization that are ripe for similar applications of AI to the tooling that we're showcasing here? And I know that there are, this particular use that we have is very Java-centric. I believe that there are lots of different application languages and platform environments where modernization and being able to use AI to optimize. I think, and this is just thinking outside of the box, that the language aspect is one, but also the types of interactions. What we find is that if you have a lot of systems of record, there's a need to have part of your application, at least, that it resides closer to your system of record. And so being able to use AI to determine which parts of your application react and interact with systems of record would help you break your monolith into microservices that part of it stays close to system of record and then the other could move into the cloud.
And I think it's also fair to say, just even outside the space of refactoring, AI can be employed for such modernization efforts like replatforming, where it can help to migrate config from an older platform to a new platform, or from runtime to runtime, or to go from VM to container, where AI can be of help in terms of automating and giving you insights into how to best migrate and set up the new config, right? So it's not just for refactoring, but it can definitely be employed for all aspects of modernization, I think.
Yeah.
There's one more question. What technologies are you using for ML and AI analysis of your code?
Okay, so the AI engine in MonotoMicro specifically, it makes use of hierarchical clustering algorithms and the technologies around that, based on standard practices out there in the Python world, like NumPy and whatnot. And we have a paper actually out there that details the AI algorithm and the specific technologies it uses that we can make available as part of our resource links.
Yeah, that would be nice. Awesome, and thanks for that question. Any other questions?
There are no more questions.
All right. Well, it's been a pleasure to share with you our discussion of how to retain the value of our Java workloads and as we're moving into Kubernetes. It's been a pleasure to be here. Appreciate your attendance and attention, and hope you all have a wonderful day. Thank you.
Thank you.